So far in this class, we have dealt with data, how to clean it, how to slice and dice it. Then we have also quickly looked at spreadsheet models. Today's goal is to bridge the gap between the data and the models. The question we are going to try to answer is, how precise should your data be, especially given the fact that your model is an abstraction of reality? Think about the ping pong ball exercise that we have done in the very first class. If you're assuming that the room has no furnitures and the room has a perfectly prism shape, then do you really need to know the exact diameter of the ping pong ball? So as you can see, if your assumptions make for a not so realistic model, perhaps when you're collecting data, you don't need to be very precise either. Then we need to look at how precise your data should be, and if you don't have a precise value for your data sets, does it really matter or not? Or in other words, how sensitive is your model, are your decisions to the precision, to the exactitude of your data set? To better understand these questions, we'll revisit two examples. The first one is going to be NPV analysis, which we'll look at now. Then we'll look at our break-even analysis example. So let's start with the NPV analysis example. This is the model that we had created several weeks ago. First, go over the model and remind yourself what we did. To give you a quick overview, we were looking at purchasing a building. The purchasing price was $3.5 million. We expected to operate the building for 10 years. In those 10 years, we were going to have some rental income, some maintenance and operating expenses. At the end of the 10 years, we expect to sell the building for $4.5 million. In these 10 years, we expected the interest rate to be 8.5%, and also we based our model on the fact that the occupancy rate is going to be 100%. Given these values for these parameters, we found out that the net present value of this particular investment would be around $0.5 million, which is a fairly large positive sum. So this makes us decide that this investment is a viable investment and we should go for it. When you run a model like this, using a basic set of values for your parameters that makes business sense, we call that the base case of the model. So the model that you will benchmark other cases and other scenarios against. Once you establish a base case for a model, the next step is to consider your parameters and see if the parameters in question are actually as precise as they are given or not. When you examine a problem like this, the first thing you should ask yourself is, are there any parameters that are explicitly defined as not to be certain? And when you look at the case description, if you revisit the case description, you will see that one piece of parameter, one item, maintenance and operating expenses, is actually explicitly defined as not to be certain in the case description. And in fact, the case description states that maintenance and operating expenses are likely to be between $30,000 to $40,000 per year. For parameters that are explicitly described to be uncertain, one thing you can do is try both ends of the range that you're given and see how the decision of the model changes. Here we know that the parameter may go from 30K to 40K, and to start as our base case we had chosen $35,000 per year, which is the middle of the range between 30 and 40K, and at 35K the decision is a buy. Well, if you look at this parameter in the 30 to 40K range, 30,000 is the best case scenario because that's the lowest cost scenario, and 40,000 is the worst case scenario because it corresponds to the most expensive, most costly scenario. In order to see how sensitive your model is to this certain parameter, you would try to see what happens to your decision at 30K and 40K and hope that the decision is linearly changing from 30K to 40K. Now, at 35K we are buying. Before we type in anything new here, let's first ponder for a moment. If the maintenance and operating expenses per year goes down from 35 to 30K, do you think our NPV will get better or worse? The answer is obviously it will get better because our costs are going down. So this means I do not need to try the best end of the range. At 30K and 35K, the decision is still make this purchase. Now let's see what's going to happen at 40K. I'm going to go ahead and in C6 type in 40,000. As you can see, at 40,000 our net present value went from 570,000 to 525,000. It did go down maybe by 6%, 7% or so, but it didn't really go down to any negative values, and it's still a fairly large positive value. So regardless of whether your maintenance and operating expenses are at 30K per year or at 40K per year or anywhere in between, you will still make this purchase. What this is telling you is your model is not very sensitive to the changes in maintenance and operating expenses as long as you're within the 30 to 40K range. What this also tells you further is if you had 2 more days, let's say, to perfect this model and you wanted to get better understanding of what these parameters are like, then you would probably not spend much of those 2 days in figuring out where does maintenance operating expenses fall in between that 30 to 40K range, because the precision within that range doesn't really have an immediate impact on your final decision of purchasing or not purchasing this building. Now again, if you are given ranges for certain parameters, the first thing you should do in your sensitivity analysis is try out different ends of these ranges for each parameter so that you can see how sensitive your model is to these uncertain parameters. If the problem definition doesn't include any explicitly defined uncertain variables, then the next question you need to ask yourself is, given all these parameters here, which ones are very likely to be uncertain and which ones are not? For example, if you look at purchasing price and selling price, which one do you think is more likely to change? Well, if you have taken a forecasting class or if you have basic business intuition, you would know that anything that's out in the future is less likely to be certain, and anything closer to the present time is more of a sure thing. So in this case, obviously purchasing price of 3.5 million is a more certain value than the selling price of 4.5 billion. Who knows what the market, what the economic situation will be like in 10 years and whether this $4.5 million is a sure thing or not. In that vein, before you continue, what I want you to think next is, of all the parameters that are given in column B and C, which ones are more certain and which ones are less certain. So try to order these parameters in a way where the most certain one is at the top and the least certain one is at the bottom. When we discuss this example in class, we will actually go over your lists and see why you have chosen the order that you have decided on.